Okay. See, I always hit record right after I yell at y'all. Okay. 8.2. Variables on both sides. What are variables?
Yeah, letters.
That's right. They're letters. Variables are the letters. And what we're talking about is yesterday, we're kind of just adding to what we did yesterday. Yesterday, you were simplifying, equations and stuff like that. Either solving it for, isolating the variable, like x equals, y equals, whatever. Or you're just simplifying it as far as you can go. But the variables were always, all the work was always on one side of the equal sign, okay? So when we say variables on both sides, we're talking about you're going to be simplifying on both sides of the equal sign. Okay, so a little tip first before I get started. Always eliminate the variable. And what's the variable again?
The letter.
That's right, the letter. On the right side first. Does it make the problem wrong if you don't? No. But it will make you crazy if you don't. And some of you might like that word eliminate, because you are that group of kids. Okay. Here we go. Example. Jumping right into examples. What if I had 7x equals 16 plus 5x? 7x equals 16 plus 5x. Okay, notice we have variables on both sides of the equal sign. There's my equal sign. I have them on both sides. Now, up here, that little tip I gave you, always eliminate the variable on the right side first. Well, they're referring to this right here. I'm going to do it in red. No, I'm not. Yeah, no, I don't know. Okay, so see, I'm referring to that. See this term right here? See that variable? We want to get rid of it first. We want to bring it over here. So does anyone have questions based on what I'm saying here? Taylor, you got to look like, okay, you get it? Anyone? I want to get rid of this variable that's on this side of the equal sign first, because it doesn't make sense to have it over there. So let's go ahead and move it over. Even if this becomes a negative, let's go ahead and move all variables that are on the right side over here. Before I do that, let me ask you, can I combine 16 and 5x? No, why not, Gabby? They're not like terms. They're different. That's right. And we're adding and subtracting. Now, if we're multiplying, we can do it. If we're doing 16 times 5x, then you would just do 16 times 5 and, yeah, it works. But when you're adding and subtracting, you cannot combine those. So let's get rid of the 5x. So Emily, you're my first victim. How do I get this positive 5x past the front door? This would be the back door. Past the back door to the 7x. No, wait. Okay, I'll say you were saying it first, and then you start second guessing yourself. We're subtracting because we want to take the whole term away, and because it's positive, so we're going to subtract 5x. We're not going to divide it because that would just be getting rid of the 5. So we want to take this whole term over there. So since this is plus 5x, we're subtracting 5x. And we end up with 2x equals 16. Now, Emily, what do I do to isolate the variable? That's right. Now we're dividing because we don't want to move the whole 2x. We want to just get rid of the 2 by itself. Since the 2 and the x are multiplying here in reality, we do the opposite, which is dividing. And we're left with x equals 8. That's what we're doing today.
Oh, nice.
Any questions about this? Yes, Michaela?
Why didn't we do divided by 5?
Because if we, look right here, if we divide, then we're leaving the x behind. See, we're just getting rid of the 2.
Mm-hmm.
Well, right here, we're wanting to take the x with us. If we divided by 5, we would have gotten rid of the 5, but left the x. Because they're being multiplied together, so if you want to get rid of just the 5, you would have to divide.
So we're not trying to get rid of.
We had to get rid of the whole 5x. You've really forgotten everything since before Christmas, haven't you? So we're trying to get rid of the whole term, so we got to look at it as they're together, like glued together. And since this is plus,
yeah, that makes sense.
is it coming back?
Yeah, because you
Okay.
said you want to be together, not.
Yes, exactly. In fact, I have on my notes from last year, off to the side. Now, you don't need to write this, but someone had a question last year of the same thing that Michaela just asked. Let's say I had this. If I want to get rid of the 5, I would divide by 5. See, and then I'm left with the x. See what I'm saying? So that's what that's about. If you want to get rid of just the 5, then you would divide by 5. But if you want to get rid of the whole term, then you do what we did here. Okay? All right. So this is all before Christmas. All right. Yeah. This is all from last year. Exactly. Okay, another example. 8x plus 5 equals x. Okay. Now, you can do one of two things. You can either do like my little tip over here by eliminating the variable on the right first, or we could actually move the 5 over, okay? I'm going to go ahead and stick with moving the variable over. So how do I move this variable over to this side of the equal sign, Michaela? How do I move this x? Because we want all the variables on the left side of the equal sign. How do I do that? Here's my equal sign. This is intruder alert. We want to move this x to this side of the equal sign. How do I do that?
I don't know, because there's nothing going on this side.
You mean right here?
Yeah.
Okay, if there's nothing there, is that a positive or negative then?
Positive.
Okay. It's positive. If there's no sign in front of it, then it's positive. So then what's the opposite?
Negative.
So then we're going to subtract x on both sides.
I remember one time when I saw this, I was like, oh, they're taking out
Wait,
the
so
X.
if it was.
They're
Maybe-
what, Taylor?
Whenever I saw this one time, I was like, oh, they're taking out the X. So I was wrong.
Could it, if it was negative x, would.
It'd be
Is that a
plus
thing?
x.
Oh.
Yeah. So then we eliminate that. If we don't have a number here, what do we pretend is there? That's right, we pretend there's a 1 here. So then that's 7x plus 5 equals 0. Any questions so far? Now, okay, Whit,
Well, where did you get the 0 from?
because there's nothing left on this side of the equal sign. So there's 0.
Wait, so in the problem that we did first, where did we get the number?
Where do we get what number?
we were left with.
Well, it was 16 plus 5x. So when we eliminated that, we were just left with 16.
Oh, okay.
Here, we only have an x here. So if I take that all away, then I have nothing there. I mean, if you want, you can leave it blank. I'm just sticking a 0 there just to have like a placeholder. All right, so Michaela, what do I need to move now?
Hmm. 7x.
No, we want the variable on this side of the equal sign. Joanne, what do we need to move now?
The 5.
Very good. Michaela, it's all from before Christmas, girl. All right, so how do I move this 5, Joanne?
You subtract.
Very good. We're going to subtract from both sides. And I have 7x equals negative 5. Okay, Michaela, I'm going to pick on you again. What do I do? We're isolating the variable.
Divided. Oh, wait. Plus 5?
No. Let's see, Cecilia, what do I do?
You divide.
Both sides by? That's right.
We just said that we're getting rid of the variable.
No, we're isolating the variable. We want it all by itself. Now, so our answer is x equals negative 5 over 7. Very good.
Wait, so we can't put it into the decimal form?
I think it's an irrational number. No, because
If you want to, by all means, but that's one extra step.
I think it's an irrational number.
Why don't you just leave it like that?
Okay.
Any questions?
I'm gonna see if it's an irrational number.
Okay. All right, I got 2 more examples. I'm setting you free. Michaela, my suggestion, go back and start doing a bunch of IXL to remind you of what happened, because it has like flown from your head. Okay,
I don't actually remember doing this before Christmas.
the intruder alert,
Wait,
I remember that.
that's what we're doing.
All I hear
It's
is
just like-
variable.
it's
variable.
But we did, that's what intruder alert
I
is.
remember intruder alert.
But that's what we're doing, look.
But this is
We're moving, look,
this whole right side thing.
it's
Is
an irrational
we're
number.
just moving stuff back and forth across the equal sign, guys, by using intruder alert. You're looking at okay, so the ultimate goal, let's go back over this. The ultimate goal is to have your letter on this side of the equal sign and your numbers over here, right? So let's back up. We have a letter with a number, and then we have another letter. What y'all are used to is a number being here. That's what we did before Christmas, is you had a number right here. Remember, that's the police officer. Michaela, you need to wake up. Okay? You're right by me, and you're like falling asleep, girl. So this used to be the police officer, right?
Mm-hmm.
Right, guys?
Yeah.
Okay, that's your front door. This was the intruder. That was you, and that was the other intruder. And y'all would move this one first, and then you would get rid of this intruder.
Yeah.
Right?
I remember that.
Okay, that's what we're doing now, except we're going back and forth, back and forth, back and forth. So when you see, in fact, you notice I'm highlighting the equal sign so that you can keep your focus on what you're doing. This is the door, and you're moving. You're trying to get the letter on this side of the equal sign and all numbers on this side of the equal sign. And you do that by doing the intruder alert, back and forth, back and forth. So like here, we want to put, oh, the letters need to be over here, so I need to move that over there. So we subtracted it. Got that. Oh, all the numbers need to be over here, so I'm moving the 5 over. Oh, we still have this one last intruder, so we moved it over. See, same thing. It just, I'm adding to it. All right. Let's see. This is another explanation of what we're doing. Variable, and remember that's your letter, and constant. What's the constant?
The number.
That's right, your number. Now, why they can't say letter and number, I don't know, but they call it variable and constant.
Because they want to confuse you.
On both sides. If you have variables, the letters, you're right, they want to confuse you. If they have letters and numbers on both sides, when they say both sides, they mean of that equal sign. Get variable on one side of equal sign and constant on other side. There, I have it in writing in case you are not hearing me. So you have it in writing and it's in the video.
Is this two different? Is this?
It's the
two
same
pages?
thing.
No, is it 2 pages?
Our notes?
Yeah.
No, I only have 2 more examples and I'm setting you free.
Wait, can you give us a real life example when we were gonna use this?
No.
We'll use it with text.
You're, are you alive right now?
Yes.
Are you using this right now? Are you doing this right now?
Yeah.
There's your real life example.
Aw.
Ah, yeah.
Do we need?
Yes, you need to know this.
Yes, we do.
All right, because
Last
do you
chapter
want to
was
make a good grade in my class?
Yes.
Then you need to know this.
Even if you don't, you need.
Miss
to-
Rogers always has a good answer for these questions. All right. So variable and constant on both sides. If you have it all, if you have letters and numbers on both sides of the equal sign, you want to get the letter on one side and all the numbers on the other. Let's do another example. 2x plus 9 equals 5x minus 3. All right, I have letters and numbers on both sides of the equal sign. I'm going to go ahead and highlight my equal sign so that I'm aware of what I need to do with these numbers and letters. Okay. Now, Michaela, in your head, 'cause I'm going to start calling on other people, you start thinking about what you would be doing. Remember, the ultimate goal is to have the x on this side and all the numbers on this side of the equal sign. Okay? So, Izzy, what would be the first thing you would move?
2x.
You want to bring the x over here?
No. 9.
Okay, so you want to take the 9 over here?
Yeah.
That's fine, you can do that. So we're going to subtract 9 because remember, Michaela, what do we want to do? We want our numbers on this side, right?
Oh.
Right?
I thought we always start on the right side.
Okay, it doesn't matter. But Michaela, what's our ultimate goal? To have numbers on this side of the equal sign, right? And letters on the left side, right? So let's go ahead and start doing that. She wants to move that 9 over there. Because it's plus 9, we're subtracting 9. We can totally do that. So now, Izzy, it's 2x equals 5x what? See, I knew it. Y'all cannot remember.
Oh, I don't remember.
Positives and negatives.
I don't know.
I don't know how y'all gonna get past this chapter then, Michaela.
-12.
Yes, yay, -12. If the signs are the same, we add and keep the sign. Oh my goodness gracious. Michael, what do I need to do now? What do I need to move?
2x.
We want to move the x over here?
Wait, no.
Michael, what's our ultimate goal?
Move 5x onto or
That's right, we want to move the letter over here. So
divide 5x.
So if I'm dividing, I want to get rid of just the 5 and leave the x. Is it what you're saying?
No.
What do you want to move?
5x.
The whole 5x, right?
Yeah.
So then how do I do that?
Subtract.
Okay, because if I were to divide by 5, I'd be leaving the x behind. So we want to get rid of this whole term. So Michaela, do you see that there's nothing here? So that's positive. So then we're going to subtract 5x on both sides. And I get negative What, Michael?
Negative 3.
3x equals negative 12. Cecilia, what do I do now?
You divide.
What?
Divide.
Yeah, what am I dividing by?
3.
Negative 3. So we're going to divide both sides by negative 3. And what do I get, Izzy?
4.
Positive 4. Very good. A negative divided by a negative is positive. Any questions? Boy, y'all better be paying attention because I got one more example and then I'm setting y'all free. Michael, do you understand how we moved this 5x?
Yeah.
Okay. Michaela, do you understand?
Mostly.
All right, and you've got an IXL for this one too. So I strongly suggest y'all start doing those. All right, look at this one. 4 times x minus 3 equals negative 2 times 3x plus 11.
Yay.
All right, Emily, what is that called? When you have a number right in front, it's called the. Okay, so you're multiplying, right? And it's what property? That's right. She's got it. Distributive property. This is where you guys struggled. I mean, to tell you, y'all, this is stuff we killed
That's
before
11, right?
Christmas.
That's 11, right?
Yes. But yesterday, y'all were adding instead of multiplying. Michaela, what is this one? Work this out for me.
4x minus 12.
Very good. Equals. Cecilia, what would this one be?
Six x
What?
plus 33. I mean, yeah.
What is this one? So what is negative 2 times 3x?
Negative 6
Negative 6 what?
x
Very good.
plus negative 33. I mean, 22.
So what? I can't hear you.
Plus negative 22.
Or minus 22. It can be plus negative 22 or minus 22. Y'all need to get used to this right here. All right, good job. All right. Michael. So we've combined all that we can on both sides of the equal sign. What's the first thing we can move?
Negative 4.
And what do we want to do with it?
Add it.
To both sides, right?
Yeah, add it to.
Okay, so we're going to add 12 to both sides. Good job. Good job. So I'm left with 4x equals negative 6x. And what is this one?
Uh, 10.
Positive or negative? Negative 10. Good job, Michael. Okay, Michaela. What do I need to move now?
Negative 6x.
Yes. Very good. So we want to move this. We want to get the letter, the whole thing, because it's attached right now. We want to get it over here. Good job. So how do I do that?
Plus 6x.
Awesome. See, you guys got this. And so what would 4x plus 6x be?
10x.
10x equals negative 10. All right, let's see. Aiden, what do I do now?
You divide 10x by 10, you go to negative 10x.
Very good, because we want to isolate the variable. We want to get the x by itself. Good job. There you go. So x equals -1. Is it now making more sense?
Yes.
Any questions?
Can we do one more exam?
Nope. We're doing page 321. Nope. Y'all need to, if y'all are forgetting how to do some of this stuff, you need to go back and practice.
We do like 5 problems.
Nope.
What?
Nice try.
She's gonna be nice and
What if
only
I
give
say
us a few.
psychology but backwards?
Ooh, can you give us a lot of problems? And that's like, no, I'm gonna give you 2.
Give us 72. See?
I'll give you 12 problems.
It worked!
6 through 28 even. It's the same that I gave last year, but that's cool. And I'm not even doing any of that weird cumulative review. All right,
Wait,
this.
So during lunch, can I go ask like the 8th graders what every single answer is?
Technically, you can.
Do you think they would
Do-
remember?
Thursday.
You can have the same papers.
Hey, hello. IXL. Let's see, you have a quiz Friday.
I guess so.
You have a test this Friday. You have a test Tuesday. And you have your IXL is due Tuesday.
Seems about right.
All right? There you go.
I
Alright.